Hello children, welcome back to the digital class. I hope you are all doing well and you might all be waiting eagerly for the next mathematics digital class, isn't it children? So, without wasting much time, let us start our session children. Let us quickly recap what we have learned in our previous class. Children, can you identify the images shown on your screen? Yes, you are absolutely right children. They are 3D figures. But children, even these 3D figures also have different names, isn't it children? Can you identify the names of these two images shown once again? Yes, the first one, if you notice, it is called a cuboid. Now the second one, you are absolutely right children, it is called a cube. Children, if you notice this cuboid, now can you tell me how many faces does this cuboid has? Yes, it is 1, 2, 3, then here there is one more 4, this is 5 and then next we have 6. So, altogether how many faces are there children? Yes, there are 6 faces. Now, apart from these 6 faces, 4 faces are called the lateral surfaces. Now, which are the lateral surfaces? Now, except the bottom and the top. So, if you remove this bottom and top surfaces, that is this green part and this green part, this is the bottom one and this is the top one. If you remove these two, then the remaining 4 faces are called as lateral surfaces. Got it children? Yes. And next, if you notice, we have seen some points over here, right children? They are nothing but common point of these 3 line segments. You can see this line segment, again this line segment and this line segment meeting at this common point. Now, this point is called vertex. So, how many vertices do you see children? Yes, it has 8 vertices. Now, apart from 8 vertices children, it also has 12 edges. Now, what are the edges here? These are the edges children, this line segment 1, 2, 3, 4. In the similar way here also we have 4. So, total 8, this is 9, 10, 11 and 12. Okay. So, there are 12 edges for a cuboid. Got it children? Now, similarly, if we consider a cube also, it has 6 faces, again of that 4 are called lateral surfaces and you can see there are 8 vertices also children and at the same time you can notice there will be 12 edges. But children, do you know how to find area of such figures, that is cube or cuboid? So, today in our topic, that is surface area and volume part 1, we are going to learn more about the areas of these 3D objects. Got it children? So, by the end of this session, you will learn lateral surface area of a cuboid, total surface area of a cuboid, lateral surface area of a cube and also total surface area of a cube. So, children, let us learn about surface area of cuboid. So, consider the cuboid shown on your screen children. Now, suppose if you are going to cut this cuboid and open it, can you imagine what is the figure which is going to be obtained? Yes children, this is the figure. You might have learned this in your previous class. But do you know children what this figure is called as? Or when you cut open a 3D objects, what do you get? Yes, we call it as net of cuboid. Yes children. Then let us mark the length, breadth and height of the. Now, if you notice here, there are 6 rectangles formed here. You can see 1, 2, 3, 4, 5 and 6 rectangles. But do you know children what is area of rectangle formula? Yes, you are absolutely right children. Area of rectangle is given by L into B square units, where L is the length and B is the breadth. Got it children? Now, here the total surface area of this cuboid is obtained by adding all these areas. That means, I am going to add area of rectangle 1 plus area of rectangle 2 plus area of rectangle 3, area of rectangle 4 plus area of rectangle 5 and finally, area of rectangle 6. So, if I add all these areas, then I get the total surface area of cuboid. So, let us apply this formula and find the total surface area children. If you notice, this is the first one. So, whose length is L and breadth is b. So, area is L into b, whereas the second one again length is L and here your breadth is nothing but h. So, L into h. So, like that we have substituted all the areas of 6 rectangles. Got it, children? And if you notice here we have LB and one more LB. So, LB plus LB is yes 2 LB and again LH HL, both are same. We have already learned, children, right? L into H or H into L, both are equal. So, here LH plus LH will be 2 LH or 2 HL you can write. BH plus BH is 2 BH. So, on simplifying get 2 LB plus 2 BH plus 2 HL. And do you notice anything common in all these 3 terms, children? Yes, we notice 2 as a common factor. Now, if you take 2 as common factor, you are left with 2 into LB plus BH plus HL. Hence, I can say that the total surface area of a cuboid, in short we write it as TSA, means total surface area. Got it, children? So, total surface area of cuboid is 2 into LB plus BH plus HL square units. So, children, let us now learn about the lateral surface area of cuboid. Okay. So, we have already seen, children, what do you mean by lateral surface? Only the 4 surfaces. That means, we are going to remove the top and bottom. So, the 4 surfaces are here, you can notice the shaded regions. So, these are the 4 surfaces, okay. Areas of these 4 surfaces, we will get the lateral surface area of cuboid. Now, let us substitute the values, children, here. So, here the second one is here h into L, b into h, okay, and here also this is b into h. And what about the area of this one, children? L into h or h into L. Now, here also if you notice HL and HL, so you get 2 HL, BH plus BH, 2 BH, 2 HL plus 2 BH. Now, do you see anything common factor in these 2 terms, children? Yes, we see 2H is common. So, on taking 2H common, you get L plus B. That means, I can say that the lateral surface area, in short again we write it as LSA. Okay? So, the LSA of cuboid is given by 2H into L plus B square units. Got it, children? So, children, let us learn about the relation between the total surface area and the lateral surface area of cuboid. Let us see. So, area of base of a cuboid. So, what is the base, children, of a cuboid? Yes, it is simply a rectangle. So, that means, area of base is nothing but area of rectangle, that is L into B square units. Then we have already learned that LSA of cuboid is 2H into L plus B and TSA of cuboid is 2 into LB plus BH plus HL square units. Now, let us open the brackets, children, here. So, I get 2 into LB plus 2 into BH plus 2 into HL. Now, let us rearrange the term, children, as shown. That is, first I am writing this 2 BH, then 2 HL, and at the last I am taking this 2 LB. Now, children, can you notice anything common in these 2 terms, that is 2 BH and 2 HL? Yes, absolutely right. We have again 2H is common. Now, if you take 2H common, you will be getting 2H into B plus L plus 2LB. Now, this B plus L or L plus B is same. Okay, children. So, I will replace it as 2H into L plus B plus 2LB. But what is 2H into L plus B, children? Yes, this is nothing but the lateral surface area of cuboid. And in 2LB, LB is, yes, it is area of base of the cuboid. That means, 2LB becomes 2 into area of base. So, I can write this as LSA. So, this part is LSA of cuboid plus 2 into LB is area of base of cuboid. So, hence I can say that the total surface area of cuboid is equal to lateral surface area of the cuboid plus 2 into area of its base. So, this is the relationship between the total surface area and the lateral surface area of a cuboid, children. I hope you understood the relationship. So, next let us learn one example to understand what we have learnt. So, find the lateral surface area and total surface area of a cuboid whose length, breadth and height are 20 centimeters, 15 centimeters and 12 centimeters respectively. So, let us see, children, how to solve such problem. So, here first of all let us write what is given to us, that is length of cuboid, which is denoted as L, equal to 20 centimeters, and what is the breadth, children? That is right, B is 15 centimeters, and height, children? Yes, height h is equal to 12 centimeters. Now, here we have to find LSA as well as TSA. So, recall the formula of LSA of cuboid, children. Yes, it is 2h into L plus B square units. Now, let us apply these values or substitute these values of L, B and H in this formula. Okay, children. Now, let us substitute them. So, 2h, that means 2 into h is 12. So, 12 into L plus B, L is 20 plus B is 15. Now, let us simplify further, children. 2 into 12, we get 24 and 20 plus 15 is 35. Now, let us multiply this 24 and 35, children. So, on multiplying that, you get 840 centimeter square. So, this is the LSA of cuboid, but we need to find even the TSA, isn't it, children? Now, let us find out TSA of a cuboid, and the formula to find TSA of cuboid is 2 into LB plus BH plus HL square units. Again, we are going to substitute the values of these LBH in this formula. Let us apply, children. So, 2 into L is 20, B is 15. So, 20 into 15 plus 15 into 12 plus HL, that is 12 into 20. Now, let us multiply them, children, now. So, we get 2 into 20 into 15, 300 plus 15 into 12, 15 12 is 180 plus 12 into 20, that is 240. Now, let us add these 3 terms, children, that is 300 plus 180 plus 240. So, you are going to get it as, yes, 720. So, we get 2 into 720. So, what is 2 into 720, children? Yes, you get 1440 centimeter square. Now, this is the TSA of the cuboid. So, hence I can say that the LSA and TSA of the cuboid is 840 centimeter square and 1440 centimeter square respectively. So, children, till now we have seen what a cube and cuboid is, and also we have learnt we also learnt the lateral surface area and total surface area of cuboid, and we have seen one example also, right, children. Now, let us move on to our next 3D object, that is cube. Let us see the total surface area and lateral surface area of this cube, children. So, if we consider this cube, so in this all the sides are equal, isn't it, children, or we can say edges also, sides or edges represent the same. So, let the length of the edge be, so this I will mark it as A and this as A, this as A, and similarly all other edges are also equal to A. Now, if you cut open this again, what is you are going to get? Yes, we are going to get the net of a cube. So, this is the net of a cube, and notice that all these 6 figures which are there, which are actually a 2-dimensional figures, they are in the shape of, yes, they are squares. So, all 6 spaces are square shaped, and also they are congruent figures, children. So, we have already learnt about congruent figures, right? They have the same area, isn't it, children? Now, children, let us find out the total surface area of cube. Now, that is nothing but sum of the areas of all these 6 squares, right, children? Just like in cuboid how we did, like that we need to add all these 6 squares, areas of these 6 squares, or even you can write it as 6 into area of a square. Why? Because all these areas are equal as they are congruent figures. Got it, children? So, what is the formula to find the area of a square, children? Yes, you are absolutely right. Area of a square is given by side into side or side square, okay, square units. Now, let us apply this formula, children, in finding the total surface area. So, your side is nothing but A, right, length of the side. So, 6 into area of a square. So, area of a square is A square, 6 into A square. What do you get, children? Yes, 6 A square. Hence, I can say that the total surface area of cube is 6 A square square units. Now, let us find out the lateral surface area of cube. So, already we have seen lateral surface area means only 4 surfaces, right, children. So, 4 into area of a square. So, area of a square is A square. So, 4 into we get A square. So, what is 4 into A square, children? 4 A square. Hence, we can say the lateral surface area of cube is 4 A square square units. Got it, children? Now, let us see again the relationship between TSA and LSA of a cube. So, area of base of a cube. So, your base is nothing but a square, isn't it, children? And area of a square is A square if the side is A. So, area of base of cube is A square square units. Then, what is LSA of cube, children? Yes, 4a square square units. And we have also learned the total surface area of cube is 6a square square units. Now, I can write this 6a square as 4a square plus 2a square, isn't it children? Because when we add these two, we get back 6a square. But why are we writing this way? Because if you notice 4a square, this is nothing but LSA of cube. And if you notice this 2a square, in this we have, I can write this as 2 into a square, and this a square is nothing but area of base of cube. That means, I can write this as LSA of cube plus 2 into a square is area of base. Hence, I can say that total surface area of cube is lateral surface area of cube plus 2 into area of base. So, children, we have derived the formula to find the LSA and TSA of a cube, isn't it children? And also we have derived the relationship, that is TSA of cube is LSA plus 2 into area of base. Now, let us apply this formula in a small example. Okay, children, let us see the example children. Find the LSA and TSA of a cube whose side is 24 centimeters. Let us see the solution children. So, first of all, let us write what is given to us, that is side of cube A is 24 centimeters. Then what is LSA of cube formula children? Yes, it is 4a square square units. Now, we will substitute the value of this a in this formula. So, we get 4 into a square, that means 24 whole square. So, children, you have learnt already about squares of numbers. So, what is 24 square? Yes, it is 24 into 24. So, what do you get children? Yes, 576. So, we get this as 4 into 576. Now, let us multiply these two children. So, on multiplying you get 2304. That means, the lateral surface area of cube is 2304 centimeters square. Now, let us find the total surface area of cube children. So, the formula is 6a square square units. Again, we will substitute the value of a. So, we get 6 into 24 square. So, just now we have seen children that 24 square is 576. So, I get 6 into 576. Now, multiply these two children. On multiplying this, what do you get? Yes, we get 3456. That means, I can say the total surface area of the cube is 3456 centimeters square. I hope you understood solving the problem children. So, children, till now we have seen again the concepts of cube and cuboid, and also we have found out their areas also, that is lateral surface area and total surface area. Now, let us see what are the applications of these cube and cuboid in our daily life, where we generally come across these objects children. So, first we will see about cuboids in our daily life. So, you can see the image shown on your screen. Yes, what is that children? You are right, it is a cotton box. So, where generally we use this children? Yes, well, packing, right, maybe some electronic goods or maybe shoes or maybe some dresses, etc., right, we use this cotton box. So, this is an example of a cuboid. Now, next, can you identify this image children? Yes, you are right, it is a matchbox, and you know why we use this matchbox, okay children. And finally, look at this image shown on your screen. What is that children? Yes, that is a room. It may be a room in your home, or it may be your classroom, isn't it children? So, those are all examples of cuboid that we come across in our daily life. So, let us see about cubes also children. So, if you notice, yes, what is this children? Absolutely right, it is a Rubik's cube, right children, you might have played also with this, right. Then, can you imagine this figure children? Yes, it is a dice, generally used for playing, right, maybe Ludo or snake ladder, etc., right children. So, these are some of the uses or applications of these cubes in our daily life. So, apart from this, you have lot of other applications also children. So, children, now let us now apply the concepts of cube and cuboid in solving few problems. So, let us start with the first problem children. Find the cost of painting of the outer surface of a closed box, which is 60 centimeter long, 40 centimeter broad and 30 centimeters high at the rate of 50 paise per 20 centimeter square. Let us start with the solution. So, first we have given a cuboid, okay, a closed box whose length is 60 centimeters and the breadth of the cuboid is 40 centimeters and height is 30 centimeters. Got it, children? Then what is the formula to find TSF a cuboid, children? 2 into LB plus BH plus HL square units. But why are we using this? He is asking us to find out the cost of painting the outer surface of a closed box. So, this is a closed box outer surface, that means complete all the surfaces, that is 6 surfaces you need to paint. So, that is why we need to calculate the total surface area of the box. Got it, children? Now, let us substitute the values of L, B and H. So, it will be 2 into L B, that is 60 into 40 plus B H, 40 into 30 plus H L, that is 30 into 60. Now, let us multiply these, children. Now, what do you get? Yes, you get 2 into 60 into 40, 2400, 40 into 30, 1200 plus 30 into 60, 1800. Now, let us add all these 3 terms. So, what do you get? 5400. So, we get this is 2 into 5400. On further multiplication, you get 10,800 centimeter square. That means, we can say that the area of the closed box is 10,800 centimeter square. But is the problem over, children? No. Here we need to calculate the cost of painting, right. So, we just calculated the area. Now, this much area has to be painted now. But what is given cost of painting? Yes, it is given as 50 paise per 20 centimeter square. Now, 50 paise can be written as 50 by 100 rupees, isn't it, children? Okay. Now, what will be the cost of painting now per 1 centimeter square? Yes, this entire thing divided by 20. So, dividing by 20 is nothing but multiplying with its multiplicative inverse. So, multiplicative inverse of 20 is 1 by 20. Now, this is the cost per 1 centimeter square, but how many centimeter square we have to paint? Yes, 10,800. So, therefore, cost of painting 10,800 centimeter square is given by 10,800 into this cost. Okay. Now, let us simplify this, children. So, 50 goes 1 time and 50 goes 2 times in 100 and 2 goes 1 time in 2 and in 10,800 it goes 5,400 times. Now, here 5,400 by 20. So, 0 0 will get cancelled, 540 by 2, which gives 270. That means, cost of painting the given box is 270 rupees. I hope you understood the problem, children. Let us move on to our next problem. 2 cubes, each of edge 6 centimeters, are joined face to face. Find the surface area of the cuboid thus formed. Let us start with the solution, children. So, what is given to us, children? There are 2 cubes. What is the length of the edge? 6 centimeters. Now, what are we going to do now? Yes, we are going to join them. Now, once you join them, what is the figure obtained, children, here? See, this is one cube and this is another cube. When we join these two, we got a, yes, cuboid. Now, what is the length of the cuboid now? Yes, it is absolutely right. That is 12 centimeters, because this is 6 and 6. So, on adding them, we get 12. So, the length of the cuboid is now 12 centimeters. What about the breadth of the cuboid, children? Yes, it is 6, because we have already seen that in a cube, all the edges have same length. Okay, children. So, that means, if it is 6, this is also 6 and this is also 6. So, only the length part is changed, breadth remains same, that is 6. And what is the height of the cuboid, children? Yes, that is also equal to 6 centimeters. Now, let us find the surface area of the cuboid. Now, children, what do you mean by surface area? Yes, it is nothing but the total surface area only, children. So, your total surface area of the box, which is in the shape of a cuboid, is 2 into LB plus BH plus HL. This is the formula. Now, let us substitute all the values, children. That is 2 into L is 12, B is 6 plus B into H, 6 into 6 plus H into L, 6 into 12. Now, let us multiply them, children. So, get 2 into 72 plus 36 plus 72. On adding them again, you get 2 into 180. So, let us multiply them, children, you get 360. That means, the total surface area of cuboid is 360 centimeter square. I hope you understood the problem perfectly, children. Got it? So, let us move on to our last problem, children. If each edge of a cube is doubled, how many times will its surface area increase? Let us start with the solution, children. So, what is given children here? Yes, a cube is, each edge of a cube is doubled. That means, suppose if I take the edge of a cube as 2 centimeters, when you double it, it will become 4. Got it children? But here we do not know what is the length of the edge of the cube. So, that is why we are assuming the length of the edge of the cube as x units. So, if this is x, on increasing or on doubling it, what will be the length of the new cube formed children? Yes, it is double means 2 times. So, 2 times x. So, you get 2x units. Now, let us find the surface area of cube. So, what is the formula children? Yes, total surface area is nothing but 6a square square units. So, the surface area of original cube will be 6x square. Why? In place of a, we have x. Now, next let us find out the surface area of new cube. So, for that also the formula is 6a square only, but instead of a, what do you have children here? The length of the edge is 2x. So, we get 2x whole square. Now, what is 2x whole square children? Yes, 2x into 2x. So, you get 4x square, that means 6 into 4x square. On multiplying these two, we get 24x square square unit. This is the surface area of new cube children. Got it? Now, what we need to do? I am going to convert this as 4 into 6x square. I am writing 24x square as 4 into 6x square, because you get the same answer, right children? 4 into 6, that is 24x square. But why are we writing like this? Because if you notice here 6x square, this is nothing but the surface area of the original cube, the first cube, right children. So, that is why I write it as 6x square as surface area of original cube. So, surface area of new cube is 4 into surface area of original cube. That means, we can say that the surface area of the new cube becomes 4 times that of the original cube. Got it children? So, children, before we end our session, let us quickly recap what we have learnt in this session. A cuboid and cube has 6 faces, 8 vertices and 12 edges. Area of base of cuboid is L into B square units. Lateral surface area of cuboid is given by 2h into L plus B square units, whereas the total surface area of cuboid is given by 2 into LB plus BH plus HL square units, and area of base of cube is given by a square square unit. Here a is nothing but the edge or the side of the cube, whereas the lateral surface area of cube is 4a square square units, and the total surface area of cube is 6a square square units, and the total surface area of either cube or cuboid is equal to the lateral surface area plus 2 into area of its base. So, children, before we complete our session, I would like to give you some homework. You are going to work out at your home and submit to your respective teachers. Okay, children, let us see the first problem. 3 cubes each of edge 8 centimeters are joined face to face. Find the surface area of the cuboid thus formed. The second question is, the dimensions of a cuboid are in the ratio 3:2:1 and its total surface area is 550 centimeter square. Find the dimensions of the cuboid. Third question is, the dimensions of a hall is 12 meter by 8 meter by 7 meters. Find the cost of painting the walls and ceiling at the rate of 15 rupees per meter square. And the final question is, if the total surface area of a cube is 1350 centimeter square, then find its lateral surface area. So, children, with this we have come to the end of our mathematics digital class. I hope you have understood all the concepts that are taught in this today's session. With this, we will stop our today's mathematics session and we will meet in our next mathematics digital class. Until then, goodbye, take care and happy learning.